So this session is going to be on developing new product and accelerating that process using some of the tools and techniques that we often think and associate with the lean manufacturing or lean thinking system, but taking it from a different perspective than might have ordinarily been taken in the past, thinking about the holistic nature of a company and thinking about how those cross-functional activities interact and relate to each other throughout the product development cycle. So we're going to get started here. Just a quick reminder of who we are. We are Nevada Industry Excellence, and I am part of the team in the north of Nevada. I'm in the lower right-hand corner there along with the rest of my team, and there's a delegation in the south working primarily in the Las Vegas, Henderson area. And at the end of this presentation, if you have a need to contact anybody about product development or ExporTech or any of the other tools and techniques that we teach and share and facilitate with people, feel free to give our team a call, and we'll provide you with that details about our website and contact information at the end of the presentation. To get started, let's talk a little bit about why we want to approach product development with some of the lean thinking techniques. And I really like this quote by Michael Hammer, who said, in America we have good people working in poor processes, and what we really need is good people working in great processes or exceptional processes. So we're going to talk about some of the techniques that we can use to accelerate the product development process. I want to make sure that we give credit to Ron Mascatelli, who is really the developer of this particular material, and we're borrowing that with his permission. I want to make sure that you know that any of the slides that we use, we're giving credit to Ron on that, and we appreciate his diligence and hard work in developing a lot of this material. With all of the processes in an enterprise, there's studies been done, and it's been proven over and over again that regardless of what the process is, whether it's purchasing, whether it's product development, whether it's the manufacturer, whether it's service installation, there's enormous forms of waste in most of these processes. And in fact, studies have shown that only 5% of the time a product or information is in the value stream as it actually having value added to it. The rest of the time it's waiting or being transported or being stored, and there's unnecessary motion and extra processing and so forth. So that's what we're trying to get at by applying some of these lean thinking techniques within the product development activities. And just to kind of take a 10,000-foot view of this thing and realize that there's a lot of overlapping interests. You've got the customer obviously has a problem they want solved, or they might have a known need, or maybe even an unknown need that you're trying to fill with a new product. So there's the customer's interest, the production has their interest, obviously the owners or stakeholders in the business have their interest, sales, engineering, installation, and service, they all have their overlapping interests. We've got to find those areas where those overlapping interests kind of congeal into a shared interest and build on that so that we all work toward the same objective, and that is to provide the customer with what they need and provide ourselves with jobs and profitability. So one of the first pushbacks I get when I go into any sort of an administrative process to apply some of these techniques is, in engineering particularly, I hear, well, you can't map my process, you can't value stream map my process and use the techniques that you would in a shop or in a manufacturing environment. What I do is too creative, and there's no way that you can map this process. And the truth is, we have evidence that we can map any process, whether it's administrative. I've worked with governmental agencies, and new product development is no different. It is just simply a process, and while there are variabilities, certainly any process can be mapped, and we have evidence of that, and we're going to just share a case study before we get into the tools and techniques. A case study that kind of demonstrates that any process, including new product development, can be process mapped. So what we're really after is to take a process that is usually convoluted in its path through engineering and sales and production, manufacturing, preparation, and straighten out the line so that just like the Japanese say about manufacturing, if you pick it up, finish it, do as much as you can to the information in this case before you hand it off, and eliminate some of this convoluted flow that often happens in our administrative processes. So that's the 10,000-foot view. We are going to use a process just like we would in manufacturing called value stream mapping, and just like a roadmap, it kind of maps out the telecommunication and the planning and the engineering and everything that goes into it just the same as you would within a manufacturing environment, and we're going to show you how that works. I want to kind of reinforce for those folks who have not joined us before the idea that we want to key in on a new metric, and that metric is called the value-added ratio. And in mathematics, a ratio is expressed as it's shown here, either 1 to 10 or 1 to 100, or in this case 1 to 1,000. We want to focus on reducing the non-value-added activities. A value-added ratio that would be considered world-class is 1 to 10, which means for every minute we work on a product or a process or engineering a new product, for every minute we work on it, it doesn't sit around for more than 10 minutes having no activity associated with it. So I can tell you that my experience shows about the average is about 1 to 300 or 1 to 350. When you look at most administrative and manufacturing environments, the value-added ratio means that for every minute they work on it, it sits around for 300 minutes or so. We want to reduce that down to where we're approaching world class, and the tools that we're going to show you today that Ron and others have developed get at that. It extracts the non-value-added activity, and that's our goal. So again, a bit of a review. The term takt time we're going to throw around a little bit today. Not too many administrative processes think in terms of takt time or the rhythm at which they produce their information in this case. Takt time is a simple calculation. It's simply the available time divided by the demand equals takt time. So in the course of an 8-hour day, you'll have about 480 minutes of available time. If you were producing 120 widgets, you would be having a takt time of 4 minutes. Or if you were producing 120 work orders, or if you were producing 120 blueprints, your takt time would be 4 minutes per unit. So not too many administrative processes think in terms of takt time, but we're going to show you an example where they did. This is a company that makes spiral air bladder shafts for the paper manufacturing industry, and so these shafts are of every size and description. They have to, each one of them, be engineered to order, because some of these paper manufacturing machines are kind of built one-off. They'll never make another one like it again in their life. So it's really highly engineered to order, and a lot of design goes into this thing based on whatever the configuration of the machine is or what the process looks like. So I'm just going to share with you a case study real quick before we get into the tools that kind of describe how this process can work. So this particular company we're going to look at shall remain nameless just for their security purposes, but what they had was a lead time of 14 days. So it took them 14 days to, this was not the lead time for the shop, this was the lead time for the office. So our project scope was from the purchase order receipt for a new product through material control and engineering to get it to a shop drawing, which meant there was a lot of design and basically new product development. So their lead time was 14 days through the office. Their value-added ratio is not the worst I've ever seen. It was 1 to 147. So for every minute or for every hour they worked on it, it sat around for 147 minutes or hours. The number of transactions were 10, greater than 10, so it went from desk to desk 10 times. We also counted the number of screenshots that it took to produce that through engineering and through purchasing and through all the other activities that had to happen for developing each of these new products. So the number of activities, separate activities, even though it went through 10 people's hands, there was 36 discrete activities that had to happen, and those orders traveled about a half a mile through their little office, and you'll see the spaghetti diagram here in a minute. So their objective was to reduce those lead time, reduce their lead time by 50%, reduce their defects because they had a high rework problem, reduce the number of required steps but also reduce the distance traveled and the paperwork associated with developing this new product. They had a lot of redundant forms and a lot of redundant screenshots that they had to go through. So those were our boilerplate objectives. Now their takt time, excuse me, was actually based on the fact that they needed to generate about 12 orders per day. So in an 8-hour day, 480 minutes divided by 12 meant they had to produce an order about every 40 minutes. Again, if you look at their before condition, it was about 14 days of throughput time for them, and you'll see how remarkably low they got that compared to that 2-week lead time. So the first step was to use what we call a deployment flow chart. A lot of people call these swim lane flow charts, but we mapped out the entire process. We thought it was just going to take a couple of flip charts to map this out, but we ended up having to go around this phone here and keep going. It just got more and more convoluted as we go. And every one of these yellow post-it notes had to go get a timing, an observation by the Kaizen team, and that's what you'll see on the next slide. Every one, this was step 70 through 75, which was reviewing the sales order. Scheduling currently did that. And then there was a red line that happened by the sales order, by the sales department. So there was all sorts of comments and observations made in addition to the actual timing. So when people say, and then we got that pushback on this project too, they said, you can't value stream map our process. It's too variable and it's too creative in nature. Well, we figured out the quantities, the percentages of the different kinds of orders that they processed through this engineering department, and we did find out there was a way to value stream map it, and we found out exactly how much each of these activities cost. And then the team got together and started brainstorming alternatives, because it was going 2,200 feet through their office from the sales department to production engineering to CAD, drawing to drafting, and on into checking and rechecking back and forth. What they identified was that up here in the top of the screen, you'll see green representing value added, yellow representing not necessary, non-value added activities, things that were either by company policy or customer required or maybe a governmental requirement. And then there was things that were absolutely unnecessary that were red. So if you look at the green, it's probably less than 25% of the time spent on an order. And so it was a huge opportunity for improvement. And what they saw by doing some tools like mind mapping to identify the opportunities for improvement, we won't spend a lot of time with this slide, but just a very visual way to try to identify what is causing them engineering delays in the process. We identified the right number of people to use in the process and redistributed the work. In this case, you can see that there was 14 drafts persons, because that was the most significant amount of work in developing blueprints for the manufacturing shop. But we divided the work among 8 people, basically 8 different departments, if you will, and then positioned them in such a way that they could actually pass the material without having to walk across the office to do that. So here's the result of our simulation. Their previous throughput time, again, was 14 days, or 106 hours the customer would wait. And to be gracious about this, we weren't counting the weekends or the evenings. This was just 106 hours of 8-hour days. They had 99 hours worth of backlog, or work in process inventory, you might call it, information waiting to be processed. Their new throughput time is 1 hour. So basically a 99.1% reduction in throughput time. The previous distance traveled per order was 944 feet, and the new distance traveled was 50 feet, so that was a 94% reduction. And the previous number of transactions or handoffs between people was actually determined to be 11. Now they handed off 4 times, and that's a 63% reduction. So if you ever get the pushback that says, somebody saying that you can't value stream map or improve a process that's administrative or creative in nature, I can tell you we have evidence that is no longer a valid argument. So one of the common phrases you'll hear when you hear people talking about product development is they say, well, we need to fail early, fail cheap. What we probably need to think about is a different way of thinking, and that's why fail at all. And so when you're developing a new product, obviously there's a risk involved. You can't completely eliminate the risk, but we want to find out as much as we can early and use what we learned from developing previous products so that we have the best chance of taking a product from concept to delivery to the customer with the least chance of failure. And that's what these tools that we're going to show you are meant to do. So I really like this slide. This is Ron's slide. He says, you know, why even think about lean in terms of product development or synchronized product development? Well, because you're thinking about profits, and we got to think about the per hour of design time. We often give a lot of attention to the costing out in the manufacturing environment, but do we really think about takt time and throughput and flow and value added when we talk about the administrative processes? It's all about the profits of each hour we invest in that design time. So we want to use efficiently and effective utilization of our designers and developers, draftspersons, all the people involved in from sales on down to service and installation. We also want to think about the closed loop corrective action and bringing that information back to the beginning if we find something in the installation or servicing and make the next project even better. So all of these things get at that wasted time, which is the enemy of every business, and Thinking Lean provides those tools. So when you think about any business, if you think about the engineering department and the product development process as a profit center, we all put work into that in order to achieve that product that's ready to sell, and which will result in profit. But in between the work and the profit are many elements that would be deemed unnecessary or non-value added. So just a couple of examples here. Poor handoffs, missing information, lack of information, redundant effort, all these things result in taking money out of the cash register instead of putting money into the cash register. So one of the things that we're trying to achieve here is make sure that by accelerating the product development process, we're able to hit the right time to market, because there's kind of three times that typical products are launched. If you're in this area, which he's identifying as the A area, we're early in the growth of the product, and this is where we want to be when we want to release the product. But most of the time, it's not until B or C, and by that time the product is already matured and maybe the market is saturated. We want to use this kind of a model instead and launch early enough to where we can capitalize and get the monopoly, if you will, on the profits. And as that product matures or the market gets saturated, then let somebody else take that piece of the business. But we want to get it when the market is rich. So again, just a reinforcement of the three kinds of ways that we can work. We can either add value, we can do things that are necessary that enable things to happen but would probably be deemed non-value added, or the worst of all, which we consider the target-rich area, which is the non-value added and unnecessary. And that's what we want to target in our product development system. So most product development goes through a process which you would call kind of throw it over the wall. Marketing finds an opportunity, explores new markets, and they give some engineering specs to the engineering department, and then because of problems with prototyping and being able to maintain the tolerances or whatever, that gets thrown back to marketing, and they revisit that and give them revised specifications. When they finally get a design that they're satisfied with, they throw that over the wall to manufacturing, and then because of unit cost, it gets thrown back for modification and engineering changes, and finally, if we're lucky, it launches. But we don't want to do that over the wall kind of a process. What we want to do is focus on an improvement. There's what they call a phased gate development process, which is better. It's not the best, though. This is used by NASA and the Department of Defense when they have huge projects that have many subcontractors and it's hard to manage. They use this process, which is better. It goes through the concept and planning and through design, prototyping, execution, and so forth. And there's milestones or gates where there's communication between these activities and entities, but still it's kind of highly structured and heavy-handed in terms of its control. And there's not a lot of things that can be done in parallel. This has to be kind of done in series. And what we're going to suggest is that a lot of this might be able to be overlapped if it was done with what we call the Nautilus learning system, and which we'll explain in a few minutes. So this is better than the old over-the-wall version, but it's maybe not as good as it could be. So we're going to explore alternatives to this. Some of the reasons that the phase gate process is not viewed as perfect, especially for make-to-order or what you might call contract manufacturers, is there's too many reviews, there's too many mandated activities. It's difficult to scale it down when you don't have as huge an when you're a smaller operation and people wear multiple hats and so forth, and it just distorts the critical path. So it's not perfect. What we're gonna explore today is something we've called the Nautilus development system. This was actually suggested by Mary Arbutini, one of our project managers down in Las Vegas, and I really appreciated this. She says she has a sister who's a teacher, I believe a third-grade teacher, and when they're exposing their students to new concepts, they use what they call the Nautilus knowledge development system, and I think it really applies to new product development. And so think about this. Think about a teacher teaching the students about, let's say, Abraham Lincoln. And as they go through the development of reading and writing, they move into history, and maybe she explores that a little bit deeper now with some history about slavery and the Civil War, and then the Civil War leads her to the subject matter on geography, but it's still about Abraham Lincoln, and she talks about the North and the South. And in math, I mean, maybe they teach them the rule of ratios based on, you know, the Civil War. And back to reading again, maybe they do a book report on the last brother, a Civil War tale, and so forth. It goes on and on and on. The knowledge keeps growing, but always about the same basic subject matter. So as they make their way through this Nautilus of knowledge and this growing information that they're sharing together, it builds a stronger base. And so when you are exposing your product development team, realizing they each have their own expertise, they each have their own areas of things that they would consider of greater importance than maybe a different team, they can help each other understand the push and pull and the overlaps in areas of importance. So one of our other project managers came up with this one that kind of shows that if you're testing a new product concept against the voice of the customer, sales and marketing might take that on, but then as it goes into design and engineering, they're verifying that concept and even measuring whether it's even viable or not. And so as they grow together in knowledge, and every time they do a new product development, they've learned from the previous product developments, they grow together and they're able to expedite and accelerate the next product. So just kind of want to introduce you to that idea of the Nautilus knowledge system because we're going to use it throughout this presentation. What we're trying to do also is define early on, you know, what are we trying to solve for the customer? The customer has a problem. That's why we're coming up with a new product. There's a gap. There's a gap between the current condition and the desired condition. We need to capitalize on that. So our solution for that is utilize a systematic approach. And if you're familiar with the definition of lean, it's a systematic approach to identify and eliminate waste. Well, this is a systematic approach to identify and eliminate what the problem is for the customer. So identify the root cause of the problem that's given either the knowledge gap or the gap in what the customer needs are compared to what the available offerings are in terms of products. So that's our goal. Just define define that gap. And so Ron has come up with a very visual, I love this slide, he comes up with a very visual 10,000-foot view of how to manage a new product development. Start by defining the problem. Start by defining the market requirements. And then there's going to be some project planning. Obviously, you're going to have to resource the thing based on whatever the scope of the project is. Identify the risks early on. That way you don't have to fail. And then there's some project management that has to happen in terms of who does what and by when, and we'll show you some tools for that. 3P, if you're not familiar with that process, comes from Toyota, and I can tell you that Pella Windows in Pella, Iowa uses this, and they're experts at it. But the 3P stands for Product Process Preparation. So we'll talk about using Kaizen to address cost reduction before you do the design freeze. So there's going to have to be a review of the project as it's made its way through the development phase. It's going to have to at some point be reviewed and frozen so that production can begin working on it. So a very lockstep, systematic approach, repeatable and robust, to make sure that every time you develop a new product, the risks are mitigated and you have the best chance of success. So one of the beginning points, of course, is to make sure that you're defining what the needs of the customer are. And so Ron uses a process here he calls persona briefs, which say, and I just put one together, kind of filled this out fictitiously, but let's say we're going to design a new hands-free phone that maybe it's the size of a wristwatch, and we got a person, Chuck the CEO, and we kind of build a case that says this is how Bob operates during his day. These are the things he's had trouble with before with his cell phones, and so you build one of these for all the people who might be a customer of your phone in this case, and you're trying to design the voice of the customer based on what their problem is. What problem are we really trying to solve for the customer? So this is kind of step one, and in our two-day workshop that we teach, I think we have 3 or 4 persona briefs that we give as handouts to the team so that they can kind of develop then what the marketing strategy would be and what are the specifications that you would need to satisfy or solve the problems of the customer. So the next step is to develop what we call a voice of the customer, prioritize what we call differentiators. So in case of my example of a wristwatch cell phone that would be hands-free, is it important that it's hotspot capable? Is it important that it's waterproof? Is it important that it has a color display? Is it important that it has a camera on it? So you measure that against, in this case, we got Chuck and we got Bob the builder and we got Stella the student. They all have different needs. They all have different things that are important to them. So we're trying to identify who our most likely customer is and develop a product around the needs or the problems that we're trying to solve for that customer. So this is one of the tools that Ron has developed, and I think it's a powerful one. This leads on to the next step, which says how satisfied are the customers with the current offerings? Because we have competition, we're going to look at this column right here that says this is where we're at, this is where our competitor A and B is at, and oops, sorry. And based on the relative buying importance we determined from the customers on the previous slide, we're going to say, you know, if we have an equal footing with our customer, there's really no need to match them in terms of what he calls parity. But if there's a huge difference in what the competition offers and what we offer, there's a great need to match or to meet parity in terms of what is being offered. So it helps us identify where the opportunities to distinguish ourselves or differentiate ourselves from the competition might be. He takes all of this data and boils it down. I know this is an eye chart. I'm going to blow each quadrant of this up, but he builds a case for a product, and again, this is a way to help yourselves not fail. We don't want to say fail early, fail cheap. We don't want to fail at all. So even before we started investing a lot of time or energy into the development of a new product or service, we're going to take a look at every quadrant here real quick and just say whether or not this makes business sense. Can we actually make a case that this is a valuable use of our time and energy and resources? So I'm going to look at this quadrant right here first, blow it up a little bit for you. It just describes the product, what are the key differentiation features in this product, what are the characteristics we're going to have to match. And so we just kind of build the text here about what the customer is going to find important and what problem we're solving for them. And then we come over here and we decide what are the likely sales for a product of this nature, and what are the target prices, what are the manufacturing costs going to have to be in order for it to be a profitable venture. And he has a calculation which we can provide you a copy of this spreadsheet if you want to email us your email address. We'll give you a copy of this where you can put your own numbers in. But it says, it calculates what he calls the net present value. What's this project worth if we're selling this much on a monthly basis at this price with this much cost, and a fixed cost, let's say a non-recurring investment, whether that's engineering time or new equipment, non-recurring investment to develop this product. And so what is the net, therefore? So that's one piece of the puzzle. Then you ask yourself the question, does this support our existing customer base? Does it contribute to the product line long term, and so forth? And so you end up getting a score, a strategic score. How important is this strategically to our business model? And then the last quadrant is that takes all those values and puts them together and says, it gives me a score that says, okay, this project rates a 105, and if the next project rates a 30, then it's pretty obvious which project I ought to be focusing my time, energy, and resources on. Now, no one number is going to tell you whether or not you should design a project, develop a new product or not. It's still going to come down to the intuition and knowledge of the steering team within your organization. But this is just a set of tools, and it's another tool in your toolbox. So, obviously, at the beginning of a project, you're identifying all the things that this new product must have, all the things that it could have, and then all the things that it should have. And as you move forward, developing a schedule and managing the resources within your organization, you're going to have to probably make some tough choices to say, well, we can't eliminate things that it must have, but in terms of the time available, we're going to have to reduce a few of these things that would be nice to have. And so as the schedule slips or costs grow, we're going to make some business decisions. So it's one of those things that even though we develop a business plan, we know that it might change over time as reality sets in. One of the other tools that Ron employs is to help identify what is the function, not only what problem are we trying to settle for the customer or solve for the customer, but what is the function of every one of these product features. So something as simple as a pencil, you think about the eraser, the paint on the pencil, or the lead in the pencil, what is the actual function? If you name them, it's easier to decide whether that's something that is a must-have, a nice-to-have, or it should have. The Japanese have a technique they call the 7 ways. And so let's say that we're designing a new electronic cabinet and I need to affix some wires to the side of the cabinet. Well, the Japanese would have you come up with 7 ways, and they say don't write it down, do a sketch of it. It's more visual. And so I could tape it to the side of the cabinet. I could put some springs on and hold it down that way, or I could put some like clay or some sort of super glue on it, or I could put a wire harness, a snap, do all sorts of different alternatives. But what the Japanese say in your development of new product is force yourself to think outside the box, and the first 2 or 3 are going to be easy. The 3rd and 4th one's going to be a little harder. The 6th one's going to be almost impossible, and the 7th one's going to make your brain bleed. But that's probably the one that's going to be the breakthrough. And so this technique of the 7 ways really challenges your team to think creatively and outside of the box. And then it's never really a challenge to come up with 7 ways. It's a challenge to narrow down which ones are the best ones. So we use a technique we call the Pugh method, which is probably named after a guy whose last name was Pugh, but it's a matrix to help you identify what is the best alternative. And how this works is, if I've got 7 alternatives, for example, these alternatives I showed here, which one has the lowest capital cost? Which one has the lowest labor cost? And so by multiplying that against the weight of that alternative, I can come up with a business decision down here. It looks like alternative 1 is the best alternative. I'm multiplying each of these values times the weight and totaling that up. And what it does is it takes the loyalties and personalities out of the process and just simply helps your team decide which is the best business decision. So that's a nice technique. Keep in mind, too, that if you don't scope out a project clearly and crisply enough, you can get what they call project creep. And so if the project team has 80% confidence because they know the scope of work and the resources have been applied and they know the schedule, but if the project creeps out to a bigger scope of work, the confidence in that project goes down. The confidence that that project is going to be a viable product or service is going to go down eventually. So we want to avoid project creep by making sure that we scope out the project right in the beginning. And here's what often happens when the team thinks they know what they're expected to deliver, and then that creeps out. What they actually are required to deliver is larger than that. It means that you're probably going to miss launch dates and maybe even dissatisfy customers. Keeping in mind that there's the old analogy of the weakest link. Doesn't matter how strong you make these other links in the chain, it's the weakest link that's going to be the break point. So reinforcing other links doesn't do anything. We need to eliminate those by applying resources, training, whatever it takes to make sure that people have what they need at the time they need it, and that there's this Nautilus knowledge system is being shared in such a way that people aren't waiting or delaying their work because they have missing information. Another analogy, obviously, is the bottleneck, and using the theory of constraints mentality, we want to identify what that bottleneck is and elevate it so that it's no longer a pinch point. So making things visual, probably one of the most important things, and Ron does a real good job of showing how you can develop a time-phased project plan. This is often called a Gantt chart. So put in first the players, whoever the people who are that are responsible for this new product development. Put in any external milestones. It might be a review by the FDA or the FAA or some other outside body, by the customer possibly. These are things that are outside of your control. Lay in the actual process steps as they are developed by the team using Post-it notes, and then put some time elements to each of those and dependencies. If this has to be done before this can be done, put those dependencies in there, and then make sure that all the checkpoints and balances are identified. That will let you then back schedule your product development so that you know exactly how many weeks, in this case, or days or hours you can expect for that product to arrive at the market. I thought this was a really telling slide. As you give, let's say, an engineer more and more and more projects to work on, his percentage of value creating work initially goes up. If you give him 1, he's about 7, it looks like 65, 70% effective in terms of value added work. If you give him 2 jobs to work on, he actually goes up. That kind of surprised me a little bit. But as you give him 3 or 4 or 5, his percentage of value added work and value creating work goes down. So making sure that people aren't overloaded. They've said, you know, no more than 1 or 2 projects on your desk at one time. And now I see that visually here, which is a kind of a powerful image. Another one of the tools that Ron talks about in his book is managing risk. And every new product obviously has risk, but I really like this identifying the risk priority number by multiplying the probability of a risk by the impact of that risk. And so I'm just going to give you a quick look at how this might look. If the impact is very minor, if the risk of, let's say, a vendor not supplying you product on time is very minor, there's no significant impact, you'd give it a 1. If it's very high, and it could be a project killer, you'd give it a 5. Well, in terms of probability of occurrence, if it's very low probability of occurring, not worth considering, but on the high end of the scale, it's almost certain to occur, you'd give it a 5. So if I multiply 1 by 1, of course it's a low number. If I multiply 5 by 5, it's a very high risk. It might kill the project. So if in the beginning, scoping out a project, and if you identify the risks early, it might tell you this is not a project that we think is viable based on the risks. It can help you avoid going down a path where you're putting money, resources, and time and effort and customer satisfaction at risk. So graphically, obviously 1 times 1 is 1, and 5 times 5 is 25. Anything that's out in this upper region is going to be, you'd seriously consider maybe not going down that path with that design or that service or new product development. There's a lot of systematic problem-solving tools. They all work. I was introduced to the Schuhart cycle back in the 1980s, where you plan, do, study, act, or plan, do, check, act. Now we use the Six Sigma DMAIC process, which is usually measure the variables in a process, analyze, improve, control, and define, and it's a never-ending circle of continuous improvement. Whatever you decide to use is fine. You may even come up with your own, but the problem-solving techniques in the TQM toolbox, they're perfect because they've been being used for nearly a century now, and we ought to capitalize on those and have our teams educated in their use. For example, one of the 3P events you might run, the product process preparation, is simplification, simplifying the design. So one of our project managers was an electric motor expert, and so I showed him this slide, and he said it's a pretty good example of simplification. So in your design, you have the chance to make it easier to manufacture, easier to assemble, easier to service by taking it from the old version here with all these parts and pieces to a new version, and that solves a problem for the customer, which is what new product development is all about, satisfying the customer where they're not satisfied currently with what the current offerings are. So that's a technique we use using the methodology called Kaizen, or continuous improvement. So this little flow chart kind of maps that out. You start out, you determine your cost maybe, and then you determine your actual cost. This is the target cost. This is the actual cost. Is the actual cost less than the target cost? If no, then apply some of these lean tools to reduce those costs. If yes, then you can continue designing until more cost data is known. So this is just a simple visual that says if you find a value-added target, go after it by using the traditional lean manufacturing tools. At some point, you're going to have to freeze the design. And the objective of the design review and the freeze event is to provide feedback to the design team so that they have high confidence that the product design is both manufacturable and it is of the best possible design for the cost targets. And the key outputs of this event is if there are any errors or any corrections to be made, that they get into the design early rather than before it's released to production. And this allows for the design to freeze then. And that freezing, according to one of our other project managers who did a lot of work with engineers, the only way to get them to get rid of a project, they said, was to throw them another project, because they all want to feel busy, right? We all want to feel busy. But if you don't have some freeze point, they'll just continue to tweak it and work on it and play with it. And so you got to throw them a new project, or else they just won't let it go. So getting them to let go is a critical part of that review and freeze process. Then it's finally ready for the production team, who has all of these things to think about, not only the qualification, testing and planning and launching and so forth, but might even involve developing the packaging and literature and training and installation instructions and so forth. So all this has to be prepared prior to its release to production. So many, many things to think about. And we've got a nice checklist that we can email you. It's kind of the appendix in our handout. We teach a 2-day workshop on product development, and we have an appendix that has some very nice checklists, and we're happy to provide that to anybody that's listening to the webinar today. So in summary, we just want to make sure that as we grow in knowledge from idea, from concept, from listening to the customer, from developing those relationships and trying to make sure that every one of our customers is satisfied and that their needs are met, we're growing in knowledge as a team. Each one of these entities on their own, left to their own devices, is just going to zero in on what's important to them. We need to make sure that those teams are communicating and learning together so that every time product is introduced, they get stronger and stronger in that development process. So there's that 10,000-foot view again. If anybody's interested, we're going to also be recording this webinar today so you can share it with people that are not online today. You can always visit our website, nevadaie.com, and learn about upcoming workshops, including the one that's coming up now that you've developed a new product. You want to be able to export it. Ray, are you there?
I am here.
Okay. So I thought I had the dates on here too, my bad. But 3 sessions.
February 12th.
Go ahead.
Starts February 12th on the first session, and the second session is March 12th, and the last session is April 16th. We go through a program that you end up with a export plan for an action plan for going to market with a market identified and a product identified. So it takes 3 months to do this. So we have 3 all-day sessions, and we include a coach and a intern to help do research and guide you along the way.
That's terrific, and we have some pretty good results from this from previous sessions. Am I right?
Yes, this is the national results. So this is a program that's produced nationally from centers like ours across the country, and the clients that participate in this see an average sales increase of 170,000. So that's an average. So there's and that's only in 3 to 6 months. So it's a very productive program to getting a head start on exporting or to improve an existing export program that you already have.
Okay, very nice. Well, if anybody has any questions for Ray, we'll make sure that he stays online at the end of this workshop at the webinar to make sure that he can get those questions answered for you.
Gary, it's Lorraine.
Hi, Lorraine.
Just want to mention that ExporTech also runs in Las Vegas on February 5th is the beginning day, then continues I think March 5th and April 9th. It's the same program basically, but it's offered locally in both Reno and Las Vegas, live with experts from lots of our partners in the exporting field.
Well, terrific. All right. Well, thank you for that. And I'll just leave this slide up there so that everybody can kind of get a look at that export program. We do have an upcoming class in January also, which is a 2-day class. It's only 6 hours a day to try to make this a little bit more manageable for people's time. But it's hands-on. Obviously, this is getting a drink from a fire hose today, just kind of giving you a high-level view of product development. But this 2-day class is January 22nd and 3rd from 9 o'clock to 3:30. So if anybody's interested in finding out about that, we'll make sure that we get that information out to you. We will make these slides available via a PDF on our website, and also a couple of the tools that we showed you in Excel format so you can put your own numbers in. And we welcome you certainly to sign up for any of the upcoming events, and appreciate your time and your participation today.
Thank you.
Have a great afternoon, everybody.
Thank you, Gary.